Today we're going to be working on problem 5A5. For this example, we're given that the mass of beam AB, we're given the magnitude of this moment about this arm, and we're given the length between these two arms connected to swiveling joints. We're given the angle theta as well as omega, the speed that the angular speed of those two lever arms. For this example, we are to assume that beams AO and BC are massless. So we're only going to be paying attention to the free body diagram of beam AB. So let's get started with our free body diagrams. Here we have a reaction point at AY and in the AX direction, as well as reaction forces in BY and BX direction, and a force W applied at the moment of inertia G. For the two beams, we have the equal magnitude AX and AY being applied at the end at point A, as well as the moment being applied along the length of the beam and reaction forces at point O. Similarly, we have the reaction forces at point B and point C. However, there's no moment being applied to this lever arm. So we'll go on to step 2. We're just going to be using I hat, J hat direction. It'll be the same, consistent along all three free body diagrams. For step 3, we're going to set all of our forces into vector form. So we set we have all of our reaction forces. They act in one direction, so there's not much to do there. For step 4, we move on to our acceleration equation. For this problem, we are going to be worried mostly with the acceleration of beam AB. So we've set the acceleration of AB equal to AX in the I hat direction and AY in the J hat direction. From there, we can go to step 5, where we set the summation of forces equal to our mass of AB times the acceleration of AB to get our scalar equations. You end up with adding all of our forces in the X direction, setting them equal to the acceleration in the X direction times mass, and likewise, same with the Y direction. From step 5, we go to step 6, where we use Euler's second law to find the moments. Now for this example, we realize that bar AB is not rotating because these are the same length and they are moving with each other in tandem. So our angular acceleration of bar AB is 0. So we can set that equal to 0, which just leaves us with negative AY and BY. Set equal to 0. From there, we can go to step 7, where we can use our statics equations or kinematics equations to get the rest of our scalar equations that we need for this problem. To do that, we set the moments. We need to find the reaction forces at point A. In order to do that, we have to put each bar AO and BC in static equilibrium and find the reaction forces on the AY, AX direction and BY, BX direction. From there, we can take it over here, where we can find the acceleration using the equations that we used in chapter 2. The acceleration at point O is equal to 0, so we can cancel that out. And we end up when it's all said and done, we end up with 2 equations for our I hat and J hat directions. So now we have our 7 equations and 7 unknowns, and we can solve the problem. There's a lot of substitution that goes in here, and you end up having to find the magnitude of the AX and AY forces. But with a little bit of substitution, you can get there pretty easily.